Good afternoon and welcome to our 19th annual exhibit of hydrogen and fuel cell technology. We've been discussing things here since 1995 and we're going to go back in history with our next guest. He's a veteran of this field who's been here from, I believe, day one. We'll be talking to Dr. Ulrich Schmidtchen, who's the secretary of the German Hydrogen and Fuel Cell Association, Deutscher Wasserstoff- und Brennstoffzellen-Verband. Please welcome with me Dr. Schmidtchen. Good afternoon. So, just in case there's any people here who do not know, perhaps you could tell us briefly what this association actually does, what it represents.
Well, as the name says, German Hydrogen and Fuel Cell Association. What do you expect from an organization under this name? Well, that's exactly what we do. Mm-hmm. We are the German lobby for hydrogen and fuel cells. Mm-hmm. We are doing this since 1996, and we are doing the things which you expect from an association. We bring the people together who are interested in this field. We make them know each other so that they can cooperate. We keep the members informed about important developments and events. We keep the public informed. We are doing lobby work. We get on the nerves of the politicians. And we take part in standardization and legislation as far as we can. And all these things, well, association work.
Mm-hmm. So it sounds simple, but...
well, okay, yes.
Well, if it's not, please tell us. I mean, it must be a complicated thing to do, and particularly it must have evolved over time. I believe you were actually at the first group exhibit here when this whole thing started.
Well, yes, the nucleus of what later became DWV was present here in 1995 at the very first show of this kind. And this show was also a big impulse for people to get together and to form a group.
Yeah. So you've been here for quite some time. You've been involved in the field for quite some time. Just a broad question here. How has your work changed over time since getting involved with this field to the present?
Well, at that time, almost 20 years ago, hydrogen energy was an orchard discipline. It was purely a matter of research and maybe some development, and was not widely accepted in the public. When you were told somebody, yes, I'm involved in hydrogen and hydrogen as an energy carrier, well, they gave you that look and said, aha, and please don't ask me what they thought. Mm-hmm. And, well, this was then, and today you find hydrogen and fuel cell in the programs of the governments of the big countries of this world.
Mm-hmm. So part of your mission, I heard this keyword a lot in association with your association, it's awareness, making people aware, okay? So there are things for which we have to have an awareness, pressing issues. What do we have to be aware of now? What is the sort of focus when you tell people who are not informed what they should know? What are the first things you like to discuss with them?
Well, I think the awareness, in particular here in Germany, is already on a rather high level. Many people know about hydrogen and what hydrogen can do as fuel, as storage, and so on. Many people have heard about fuel cells. Many people also know that we have a problem and that sooner or later we must switch to renewable sources and go away from the traditional sources. But I think most people are not aware how quickly we have to do this. Mm-hmm. When you look at recent studies which have been published, for example, by the Energy Watch Group, then you see that we are right in the middle of the transition, and we must do it much quicker in order to catch the train. Because a few years ago there was a lot of discussion about the oil peak. There isn't any more today. We have the oil peak. Mm-hmm. Since about 2006 or so, oil production is more or less stationary and goes a bit up and down, but not very much. And further increases of the production cannot be expected simply because the countries cannot. Mm-hmm. The gas peak is maybe 10 or 15 years away. And about coal, well, people say, there's so much coal in the ground. Well, it may be there, but this does not mean that you can buy it cheaply. And if you want to try somebody who sells the coal to you, you will have a problem.
So you're convinced that the issues are very urgent. The switch to renewables is a very urgent and pressing issue.
More urgent than many people think.
When you mention renewables, there's always this sort of shift of focus. We talk about renewable energies. People think of photovoltaics, the solar cells on top of buildings. They think of windmills, but they don't instantaneously associate that with hydrogen, which is just an energy carrier. So hydrogen is right now not a major player as energy carrier in Germany. What is going to make it a major player? Why is it so essential to integrate renewable sources, solar power and wind power with hydrogen?
Well, today we produce about 1/4 of our electrical power here in Germany from renewable sources. Some 10 or a few more percent come from wind. This trend will increase. When we look at the past, we find that the actual development has always exceeded the forecasts. So we will get more renewables in the grid and more renewables which you cannot predict, like for example wind and solar. And the storage problem will become more and more pressing. In particular, the problem to store large amounts for a long time. Large amounts may mean a few gigawatt hours, and a long time is everything which is more than maybe 3 days. And when you talk about this class, then you have little alternative to hydrogen. However, the means to store hydrogen in these large amounts for this purpose, they are not there today. They must be created, and this takes time. So we must act now in order to have it then.
Now, some people might say, things are not happening quickly enough. Right now, we're actually stopping those wind power stations. If the grid can't absorb the electrical energy, you've got a point where the energy is, it has to go somewhere, and they just dump it, basically. Instead of using that to generate hydrogen and perhaps consuming it within the existing natural gas fuel, that is pumping it into the natural gas pipeline. How feasible is it to do that right now? If we're talking about smaller quantities, if you're producing hydrogen with electrolysis, how much of that hydrogen can be pushed into the existing natural gas pipeline?
Well, the regulations, as I know, they permit to add about 10%, to replace about 10% of the natural gas volume with hydrogen. This is a level until which you will not feel very much of an effect for most consumption devices. There may be a few who do feel this effect, maybe gas turbines or the glass industry or car tanks and so on, but most do not. And when you consider just how much gas there is in any given moment in the gas grid in Germany, it's a huge amount, and this will be enough for a lot of hydrogen. So this can be some intermediate solution, okay, not really a solution, but a step, but it will certainly not be the long-term solution. But for the moment, it can help. It's a kind of a crutch.
Exactly, it is a crutch. One thing that fascinates me, if we decide to use the electrical energy generated to feed the natural gas grid, we're still not addressing one issue. That is, we think of wind power as something, you mentioned it yourself, it goes into the electrical energy grid. And there is a dramatic difference from country to country between how much energy is consumed in the form of electricity and how much energy is consumed in the form of, right now, natural gas. Most apartments and houses have their, what the Germans call Gasetagenheizung. They have a boiler that runs on natural gas. It does their hot water. It does their heating. And the amount of electrical energy they consume is relatively small. When you compare that with a Canadian home, up in the north, there is no natural gas pipeline up there. So what they do is they literally run everything, their heating, their hot water, and all the appliances in their house with electrical energy. So the question I'm working towards is, if you take that electrical energy and pump it into the natural gas grid, you still haven't solved the issue of creating enough energy for the electrical grid. Are they separate entities, or do they at some point combine?
hydrogen is not the solution or not the miracle cure for the whole energy turnaround. When people say that we need a huge enhancement of the network, that we need bigger capacity, that we need more transport capacities and so on, they are certainly right. Because we are not in northern Canada, we are here in Germany with a quite different network situation. And I think that we will not in the future replace the natural gas grid by a hydrogen grid, but the electrical power will have the dominant role. But if you want to convert hydrogen to heat, well, we have a hybrid power station here in Germany, some 100 kilometers northeast of Berlin, near Brennstoffzellen. They make hydrogen there from excess wind power. They sell part of this hydrogen to filling stations in Berlin as fuel. And they mix the rest with biogas and burn it in a combined heat and power plant. And they feed the heat into the grid of the city of Brennstoffzellen. So this is wind power to heat.
I should mention that Dr. Schmidtchen would be happy to answer questions from the audience if there are any questions. Returning to the issue of how urgent it is to move towards renewable energy, we're left with this huge problem of the cycle of demand and the cycle of supply. We never know what those winds will be over the course of a month. We never know when the sunny days will come, but we basically have a relatively predictable fluctuation of demand, and the supply doesn't suit the demand. So the more we rely on renewables, the more we need to have massive storage facilities for the electrical grid, and for whatever other source of energy we use to do our heating and hot water. So where is this storage capacity going to come that will make it practicable to use renewable energy?
Well, one really important means to store hydrogen will be in underground caverns. Because when you think that they build a lot of offshore wind parks in the North Sea and in the Baltic Seas, well, where will the power lines come ashore? They will do so in North Germany. Well, fortunately, in North Germany we have important salt stocks and other geological formations which permit the storage of gas. We are already doing this with natural gas. And the chemical industry is already using such caverns for other substances they need, for oil, for example, and even for hydrogen. No, there are hydrogen caverns, underground caverns, but not for energy purpose for the chemical industry. And this will certainly play an important role. And the good thing is that we have these formations not only in North Germany, but also in South Germany. There are also important salt mines in Bavaria, for example. And there are porous ground formations which allow this formation also elsewhere. So this will, we think, certainly be an important way to store hydrogen as energy.
You have, of course, as the secretary for the German Hydrogen and Fuel Cell Association, a lot of experience in Germany. I'm sure all of Europe is within your purview. But do you ever get to other countries and work with them? Do you keep your eye on what's going on in, for instance, the Asian countries as well?
Well, yes, of course. We are a member of the EHA, of the European Hydrogen Association, and we are also members of PATH, which is a partnership for the transition to hydrogen. And it's always very interesting to see what happens, because the basic problems are the same everywhere, and the ways how to cope with these problems, they are different. Many things are similar, but nuances and the details, they are different. Well, and you can learn something from everywhere.
We just had, before our talk, we just had Jonathan Wing on stage, and he offered his view of the status of mobile applications. And what he basically suggested is when you just look at the commitment and the quantity, we're being outperformed by Japan. That is, they seem to be moving more quickly towards the applications, automotive applications. Are we losing the race? Are the fuel cells going to come from Germany, or are they going to come to Germany?
Well, this is a global business. And there is no such thing as a German fuel cell or a Japanese or a Brazilian fuel cell. Because when you look at the car makers, they work all together. There is this new triple alliance between Daimler, Nissan and Ford, which spans all the commercial centers of the world. And there is the partnership between BMW and Toyota. They develop the fuel cells jointly and fit them into their cars. But it is certainly quite obvious that the Asians, they are progressing on this way in a very aggressive way, and that we must be very careful in Europe and in North America not to miss the train.
On that note, perhaps we can conclude our talk, but continue the conversation at the booth. Dr. Ulrich Schmidtchen is the secretary of the German Hydrogen and Fuel Cell Association. His booth is E69, so it's in that direction over there, and I'm sure he'll be happy to continue the conversation with you on a one-to-one basis, where even more information is available. Dr. Ulrich Schmidtchen, it's been a pleasure having you on stage. Hope to see you next year.
If I can.
You're welcome to it. Thank you.